Hello, this video is to help you guide the way through this Excel assignment. The intention of it is to show you how to use the Excel commands that you use and kind of point you in the right directions on the questions that you need to answer. Now, I won't be giving the answers to those questions, but I'll sort of help guide you with where to look for things and stuff like that. Anyway, so here's the page with the questions on it. So the first thing is here is the data of information that you're going to have to work with. Now, what I'm going to do is just for practice here, I'm going to just generate a new set of data. So some of the numbers that I'm using on this second tab right here, or any number I use from that tab, you do not want to use those as your numbers. This is going to go away. You're going to have that file that's already in the Blackboard that has the original numbers there. So don't use any numbers from what I'm about to do on this second sheet right here. Now, the first thing you may need to do, depends on where you're using Excel or whatever, is you may have to add in something called data analysis from the analysis tool pack. It's an add-in that you can get from Excel. See, I would probably see that sitting over here somewhere. This is different. It might look different on different versions of Excel. If you're using computers in the classroom to do it, I can certainly help you make sure it's loaded on there. Or if you have a laptop, and if not, if this doesn't help, you can probably find YouTube videos if your Excel version is a little bit different than this one. Well, anyway, what we do is we go to File, Options, Add-ins, right over here, Add-ins, and I'm looking for Analysis Tool Pack. That's going to get me the data analysis that I need. Now, it seems like you would click OK here, but actually you don't. You click Go, and that takes us. I only need that top one. If they're already, all four of those are already checked, you're not hurting anything. But that's the one that has to be added to the analysis tool pack. So I'm going to click OK, and let's see where this shows up. See, there it is. So it popped up over there to the right. So, but if you already see data analysis, when you click on the data tab, if data analysis is there, then there's nothing that needs to be done. Now I'm just going to real quickly show how the random numbers were generated, which is, you don't have to actually do that yourself. It's already on there, but I'm just doing this to get my new set of numbers. To show you, so number of variables 1, I want 200 random numbers from a normal distribution. Means 100. Standard deviation is 20. Random seeds, any 4 digits, so hopefully it won't be the same ones I picked before. 7, 3, 9, 4. I don't know. Output range, I'm going to put them in A1. Just let it go right down the column. There. So if you look at those numbers, you can see that they're different than the numbers over here, over this side. See, that's the idea. See, that's already done, so you don't have to do what that's already done for you. And then I'm going to create this other thing that's already done for you, just to show you. That's also data analysis, descriptive statistics. Input range, I guess I could have highlighted them, but I'll go ahead and just type it. A1 colon A200. I don't have a label on the first row. Output range, I'll put C1, because that way it'll just spit everything down and to the right from there. Summary statistics, that's what I want. That gives me all my mean, standard deviation, all that kind of stuff. There we go. Now I'm going to come up here and widen these columns a little bit. Okay. All right, so there's what's already done over here on this other side. Now I'm going to start with that right now. I'm going to come over here, back to the questions. Alrighty, so first question is talking about empirical rule. So I think we should go in the notes. And that will be section 2.5, I believe it is. Or whatever section it might be if I'm using a different book. No, 2.4, I'm sorry. It'll be in the measures of variation. I won't worry about opening that completely up. I'll scroll down here. Empirical rules. So take a look at that. We're going to use that. And this is where you have those three percentages, and you have to create the intervals for 68, 95, and 99.7, where you add and subtract one standard deviation. So you go back to that. Now let's come back over here. And the question's asking according to descriptive rule, 68% of the data should lie according to what? Now, see, the numbers I'm going to generate are not going to be the numbers on your answer here because I'm using those other numbers. So this will not match, but it will using the original numbers. So I don't have my tablet PC with me, so I'll just put this in a random cell. So you see, here's the mean. Here's standard deviation. Oh, I think I'll put a little color in this thing here. There we go. Make it look all nice and pretty. There's the mean and standard deviation. So for the 68%, in fact, I'll just put them as cells. That's in D3. I can go equal D3. Obviously, just do this in a calculator. Don't worry about doing it this way. Minus 1 times the standard deviation. So I got to put as D7. And then I could put equal D3 plus D7. And that creates your interval. So to do that, then you do it for that interval, and I'm going to skip over number 2. I'm going to look at the odd ones for a second. 1, 3. So you'll do it for 95, means you'll change this to 2 times the standard deviation. So it's 2 times whatever that value, right there, and then 2 on the upper end. That'll create the new interval. All right, so there's 9. I'm going to leave 95 there for a minute and not do 99. We'll just leave there. In number 5, you'll do 99. So next thing we have to do, and you'll have to do this, so you'll see me do this right now, we have to sort these values. So you'll need to sort the ones that are on your sheet, which is the first sheet, which is those right there. And to sort them, I click on that top of that A where it highlights the entire column, and hopefully this will work. I may have to just, let me see. Hopefully it'll ignore the blank cells. Data sort. I want to put it lowest to highest, right there. Well, yeah, obviously that'll work because everything, they just ignored the blanks. So there we go. Now this is important because what they're asking you to do is from that interval you just created, you want to count how many numbers from that data in that left column fit in there. In other words, and you divide by 200 to get a percentage. So let's say if 140 numbers were in that interval, you would take 140 divided by 200 and you would get 70%. But we'll do it for our numbers. So that's for 68. And then 95, you create that interval and answer the same question. Because the idea is we're hoping that these numbers are kind of close to the empirical rule. They should be kind of fairly close. So the best way to count these is not manually. So here's this interval. Now we're going back. That's the one I created right here is the 95% interval. So I'm just going to show you how to do this for 95, and then you can do it for 68 and 99. I want to go to the first number that's bigger than 63.2504. And it's going to be this number right there. Then I'm going to scroll down and kind of drag along, kind of grab the center, hold down with the mouse and pull it that far. And I'm going to stop right before that second number, which is 138,353, just under that. So let me scroll down here. 138,353. 138, okay, it's too big. There, so I'll stop right there. Now, we don't have to count all those numbers up because Excel has a nice little feature down here at the bottom of the page. It tells you the count. So there were 191 numbers in that list that fit in that interval. So now you just take a calculator. Well, I guess I don't have to do it again. I'll just go bring up this calculator. I guess I could have done that before, but that's okay. So I'm going to take 191 divided by 200. 95.5. Well, that's pretty good because it's pretty close to 95%. So the empirical rule held up pretty well here. So you would do that, make that calculation, look at your answer choices, and pick 95.5. There's how you do it. So that basically takes care of 1 through 6. Problems 1 through 6. Now let's take a look at what we've got to do next here. So we're through with that. Okay. Now it's telling you that descriptive statistics command that I showed you for these numbers on your sheet. This list right here. So it's asking you to create the descriptive statistics. I can probably leave that highlighted because you'll be answering questions from that. So we go data, data analysis, descriptive statistics. Oh, I don't want that. That's A1 through 200. I want this. I don't know why it's not letting me. Well, okay, now I did it. All right. Output range. I put C1. That's not what I want. I think I want it. Let's see if I mentioned it in the instructions here where it should go. Let's see. H1. There it is right there. So I suggested putting it in H1. So I'll put it in H1. That way it kind of fits on the page. There it is. So you take that information and so once you create that, that's easy enough. You come down here, you find the mean from that output. You know, like I'll go back to the one that has the different number. So yeah, you'd be looking for 100 point whatever. That's the mean. Same thing. Standard deviation. Okay. So we're going to pick that. So there's standard deviation. So you're just answering based on those two numbers. Easy enough. All right, now number 9. Well, when we did confidence intervals for t-distribution, we only learned the ones that were on that t-chart. But this command in Excel will help us get a critical value for a t of some other percent. So we're going to use technology here and come up with a critical value instead of the chart. So you can't use that t-chart because we're using a percentage. But here I tell you exactly how to do that. Now this is just 96% as an example. That's not what you're going to be doing. You're going to be doing 75 for your problem. So you would just type in equal t inverse. Well, I'll use this 96 and 19 just to show you without giving you the answer. Now, yours will be 19 because there's 20 numbers in that. I don't know. No, excuse me. 15 will be, so it'll be 14 would be your degrees of freedom. Excuse me. There are 15 numbers in this column right here. All right. See there, the count tells you 15. So it's 14 degrees of freedom. So make sure you use 14 degrees of freedom and then 1 minus 0.75. So let me just enter the command. This will not be the right answer you're looking for here, but when you do it what I just said, then so you'd use 1 minus 0.75 and then 14 degrees of freedom. But let me just show you how to enter that command real quick. It's real easy. Just pick some random cell down here. Anywhere is fine. Equals TINV 1 minus 0.96 comma 19, excuse me. Enter. So there you can see, so that if that would have been what we were looking for, that would have been 2.204, whatever, rounding it as there. So that's not our answer here, obviously. So you do it for that. So that's real easy. Now, using the information from 7, 8, and 9, which means the mean, the standard deviation, the confidence interval, we will go back to the notes, and you're just looking to do how to do a confidence interval for T. And that will be section, all right, where are we here? That was on our second exam in this class. And confidence interval for the mean, small samples. So we'll scroll down here and get to, here's the formula right there. Confidence interval value. So you take, so everything we have, sample mean, plus and minus the TC means the critical value. That's what we just found, or you will find using that T inverse command. That's what I'm saying. 7, 8, 9 were the mean, standard deviation, and of course the count is 15, and it's 15. So you'll take the sample mean plus and minus the critical value times the sample standard deviation, and then divided by the square root of 15 for your problem. So there you go. There's how you'll do that confidence interval. So there it is, lowest to highest. So that takes care of number 10. Number 11, it's asking you to do it for an 85%. So you're repeating it basically. So you just would just change your T inverse command, then becomes instead of 1 minus 0.75 comma 14, now it'll be 1 minus 8.85 comma 14. Okay, so I don't need to repeat that again. It's basically, so 11 and 12 are doing the same thing as 9 and 10, using the same mean and standard deviation from 7 and 8. So here's telling you 7, 8, and 11. So 7 and 8, remember, that's the mean and standard deviation. So we're using 7 and 8. But 11 is the new critical value. So all you're doing from number 10 to number 12 is taking the same numbers, except you're changing the critical value from whatever it is in number 9 to now whatever it is in number 11. That takes care of 11 and 12. 13, this is going to be a t-test, hypothesis test. Small sample, less than 30. So I won't totally give this one away, but you have to pick the right ho and ha for that wording. But like I said, I'm going to show you where it comes from. And it's in this section right here. It's all about, well, how to set up the ho and ha is the same whether it's large sample or small sample, but might as well stay in this. This is where you'll base your calculations on, is this section right here. Yeah, because there's how you get your test statistic. Let's come back over here and see. So you set up the ho and ha based on reading the problem and determining what's the appropriate pair there. Now this one, level significance of 0.025. It's going to be a one-tail test. So this one, we can use our t-chart. So it's 0.025. Now 22 is not n. I see people get that confused. N is still 15. You know, this group of problems is still based on this set of that set of 15 numbers here. You know, right here in column F. So there, it's still 15. So it's going to be 14 degrees of freedom. And then we look that value up. I won't exactly tell you the answer here, but so you're essentially looking at 0.025, one tail, (14 degrees of freedom). So you see the one tail, 0.2025, column 4, 14 degrees of freedom. There you go. That'll give you your critical value. And then you have to decide, now if it's a left tail test, it's going to be, so your answer here is going to depend on your answer on 13. Of course, not only do you have to have the correct number here, but if it's a right tail test greater than, that means it's going to be one of the two positive T's like that. But if it's a left tail test, it's written as less than a negative, so it's going to be one of those two. So that answer depends on what answer you pick for the one before. That's your decision rule. All right, now it says calculate the test statistic. Oh, should go back to those notes. I should have just downloaded that page to keep it open. Instead of hopping back and forth. That's all right. And I just had that test statistic up there a minute ago. All right, this time I will download it and open it up. Oh, there it went. So there's that test statistic. So you'll take your descriptive statistics from here, right there, and you'll take the sample mean minus the hypothesized mean, mu0, which is the 22 you're testing against, divided by the standard deviation, which you'll get on that chart. The descriptive statistics divided by the square root of n, which is 15. So we calculate that. We decide which number it is from these four. Okay, then number 16, just like you would do with hypothesis tests, you check to see, once you establish what 14 is, your rejection region, you could draw a little picture. Then you can decide if the answer from 15 falls in the rejection region or does not fall in the rejection region. That's how you'll answer number 16. Is, did the answer from the t-value from 15 based on the answer to number 14, does it cause you to reject or not reject? So these three questions are all in that same section of notes I pulled up. Now here, so this regression analysis. So I'm telling you how to do that here. So you take regression and data analysis. You indicate the columns that are the Y range of values. It's where they put y's above x's. And then you tell it, you don't have to put it puts the dollar signs in there automatically. You don't have to. You can highlight the cells. So we're saying that, is the grade a function of hours studied? So if you highlight all these, whenever you bring up the y values, you highlight all, if you want to. Now, to do it this way, if you highlight the column with the title, and you might as well, since that's the way I wrote the instructions here, you see how that box checked labels. So that just means, you want to highlight that top one with the label so it knows that the first column is a label and it won't confuse it with the numbers. So you do it for the y's first, and then the x's will be second. And then I put N1 as the output. But as I explained in the writing up here, is do not use these values, because I use different numbers for this. So this is not the output you use to answer the questions number 17 through 20. As I mentioned here, you have to use the output. So this one would be, if these were the numbers, it would be 58.433 plus 4.79x. Remember, the bottom number goes with x. The top number is the y-intercept. But see, obviously these aren't the right numbers. But they will be when you generate your output. Now, number 18 is really easy. Predict the grade for someone who studies 5.5 hours. So you would take the answer that you got from the problem above, and you would just put 5.5 in for x, whichever one of those is the right one. And then you calculate that, and it'll be one of these answers. That's not too bad. So once again, I'm emphasizing from your regression output, not the one I have here. Find the coefficient of determination, which is the percent of variation that can be explained by the regression model. That is shorthand for R squared. So that answer will be, so here it is in this output, that's the number. So that's the number you'll use on yours. So roughly 0.66, so about 66%. Like I said, that's not the numbers you use. You'll use the one on yours. And number 20, we use the p-value for the slope to test the null hypothesis that the slope is equal to 0, and whether or not the regression model is statistically significant. Another way I mention this in the notes is that also means that x is a useful predictor for y if we reject the null. So if we reject it, our model's good. It's statistically significant, and we can be comfortable using x to replace y. So let's see from this one, our p, and using the bottom row p-value. So you use that bottom row, and that's definitely going to be less than whatever your alpha is. So that p-value is less than alpha, and we would reject the whole, and our model is statistically significant. I'm not saying yours is going to be for sure, but I'm just telling you how to do it based on these numbers right here. So yeah, this couple of these answers are not even, so the A could never be right, because if you're rejecting it, that means it is significant. So that A could never be right. So, and then C is not right either, because if you fail to reject that, and they're saying the model is statistically significant, and that's not true. If you fail to reject, it's not significant. So basically, it's going to be either A or D. And that concludes your Excel assignment.